Hello everyone. We are participating in Smart in the Hackathon 2025. Our team name is the Megahertz Mavericks. Problem statement ID is 25116. Our problem statement title choose one from student innovation in the theme of renewable and sustainable energy. We are all already known that energy is the important one for all living beings. Example of solar energy. Solar energy only created energy only in the summer season, not winter season. Then wind energy only depends on the location based. But here we produce the electricity or energy using the temperature. How we generate the energy means using the thermal electric generator.
So, our team, the Megahertz Mavericks, has come up with a solution in order to harness the waste heat energy and directly convert it into electricity. So, generally, the unused energy have been generated from the boilers, furnaces, engines, exhaust, etc., in which the tons of heat energy that have been going vain. So, our solution is based on the Seebeck effect, which is employed by the thermoelectric generators. So, thermoelectric generators is nothing but a tile-shaped device which is shown in the image below, which have been a proven prototype by ourselves, and it has been tested and demonstrated with the over 80% of waste heat recovery, and it can be scaled to the real world applications. The Seebeck effect is generally based on the temperature difference between two dissimilar metals, which converts it into in which it is used to convert into electricity by the thermoelectric generators. By this, we can generate clean and continuous power resource without moving the parts, and the output will be at higher efficiency, and it is a reliable source. So if we see the flow of our project, so it is based on a thermoelectric generator which is placed along with a DC to DC converter, in which the output from the thermoelectric generator can be powered to the DC sources by obtaining the amount of electricity that is collected from the thermoelectric generator. Also, it has a voltage sensor in order to detect and measure the amount of voltage that has been generated by the tech. Also, it contains a thermal imaging device to detect the heat presence, as well as we have Arduino, Wi-Fi sensors, Bluetooth sensors in order to employ the real-time monitoring of this system. So this system can easily integrated with the this system can be easily integrated by using it directly into the household devices, for which we require limited amount of power, as well as for the industrial plants for which we need a higher amount of power. So it has been a truly a universal solution. So what is the uniqueness of our project? This is a custom tech design which are engineered thermoelectric system which can be directly placed onto the industrial boilers, exhaust, as well as for the all heat generating devices directly onto it. By this, we can generate more amount of electricity with higher efficiency. So this is a dual scalability device which can be used for the household devices as well as for the industrial plants based on their requirements. So this is a proven prototype. This is a proven prototype which we have already tested and demonstrated, which gives more than 80% of waste heat recovery. By this, we can say that it will be a real world feasible device. So the smaller amount of a project which has been showcased by using the iron box, which is used as an heat generating device. By this, we are placing a thermoelectric generator below it, which is a tile shaped device. By this, we are generating the electricity from the waste heat that have been generated by the iron box. So it is it is easily integrated by using these custom tech modules, which can directly mounted onto the hot surfaces without any redesign, along with the heat sinks, phase changing materials, as well as the AI control. These are integrated in order to maintain the stability of electricity generation with more than 95% of power routing efficiency. So why we are unique? So this is an proven innovation with our own thermoelectric design, which has successfully achieved more than 80% of waste heat recovery from the sources which generates the unused energy. By this, we are demonstrating a scalable green solution for households, vehicles, industries, as well as for the purposes we can scale our own device for the requirement. So the technical stack will be explained by our teammate.
Now let's see the technical approach of our project. And if you see the components, first of all, I would like to say that the components required for the project is very less. So we are using the components which are readily available in our market itself. So let's see first what is the flow diagram of this project. So now we are using our main important component, which is TEG module. TEG module stands for thermoelectric generator modules. And from the thermoelectric generator modules can able to generate electricity based upon the temperature difference we are able to creating. And also from the atmosphere also we can use the atmosphere to create the temperature difference, and also artificially created energy which is exhausted as waste in terms of heat energical waste. We can able to convert them into an electricity. So okay, so the thermoelectric generator modules gives the DC voltage. Actually the generated voltage is DC, and we are providing the generated voltage into the DC-DC boost converter. So that we can able to boost the voltage. So the DC-DC boost converter is a custom module. So based upon our power requirements, we can able to design that module, and we can able to generate the voltage which is required. So actually from that module we are going to store it in the battery. So the battery storage also, now we are currently using up to a 36-volt battery for because we are for the demo purpose we are using a small scale of a battery, like we are providing to glow just one LED bulb. For the future purposes, we are planning to get more than like we are using in the day-to-day life, like inverter batteries. We are trying to implement that in a larger scale. So okay. So from the battery, we are using that into a DC usage applications, because nowadays we are using so much of applications in the appliances in the DC. So we don't need any type of rectifiers or converters to convert the DC into AC or AC into DC. In case of any AC applications, we can directly use some type of inverter, and we can provide the AC voltage to the appliances too. So this is the overall setup of our flow diagram. So where we are pasting the thermoelectric generator, pasting means where we are keeping or where we are employing the thermoelectric generator is particularly on the boilers and furnace and exhaust. So why these three places means, when you see in the real-time applications, we are generating heat, steam, and the steam is used to run the boiler, and we are getting electricity. But so much of heat from the steam points has been wasted there. So there is a typical loss of energy over that period. So we are recovering that heat, and not only from that heat, any places where the temperature or the any form of heat energy is wasted, we are using that too. So okay, and this from the boilers, we are using the TEG models, and then to the DC-DC boost converter, and then to the battery grid, and we are using it in DC applications, and if inverter needed, we are using that too. Okay. What makes our project as a smart grid? Because smart grid means that optimal use of energy. So we are using typical uses of sensors and microcontrollers. The main microcontroller we are using is Arduino, because it is readily available and very low cost also. So we are using and voltage sensors, two types of voltage, two different voltage sensors. Why? Because to detect the input voltage from the tick, and also what is the voltage that has been rejected, not rejected, actually the output coming of the DC-DC inverters. So we are going to detect the both the voltages that is coming outside. So okay, and then we are also upgrading the data into the cloud. Why we need a cloud or any type of IoT based application means we can able to predict the what is the voltage when at this temperature, and also based upon the environmental circumstances we can also uh, detect what is the expected output of the system. And based upon this, and we are also placing an LCD display, and most probably, and high voltage indicators too, because due to we won't get, but if there is any chance we can able to get a high voltage, we want to intimate the user we are going to using, right? And also we are using some type of breaker circuits to control that too. And LCD display is to denote the user which is using that system, to about the system, about what the current temperature and what the voltage has been generated, and also the IoT cloud platform we are typically using and ThinkSpeak from the Networks, which is a standardized IoT cloud storage platform and can be also used for the analyzing purposes too. Okay, and then we are using a web dashboard application for the definition of how much voltage we have been generated, and all those stuffs can be keep in a single panel of a web application. Okay, so let's see. I tell what is the flow diagram and the flow of the overall circuit, and let me tell what is the main technology stack we are using for this. For the Arduino IDE, we are writing the code in a C++ module and C++ language, and the Python we are using data processing and AI model. Particularly in the AI models, we are using a random forest or some type of decision tree based upon or best. Actually, we have predicted and done the best outcome can be done in the random forest. So probably we are going in the random forest algorithm. So okay, NumPy, Pandas, and Skitlearn and usually used for the data language and machine learning. And then Blink IoT platform. For the Blink IoT platform also we can able to be integrate, because we suggested there would be a better knowledge for if you have a separate separately cloud based, and then we are using ESP32 and mode MCU. I mean that is a Wi-Fi enabled microcontroller, because we need anything which is related to IoT leads with the internet, so we need the ESP32 control. And then the DC-DC converter, as I said, we can able to customize the output voltage which is required based upon the design of the DC-DC converter. But now we are currently using the Excel series for the DC converters. And lastly, the LCD displays and sensors, which is already I've shown. So you can in the below diagram you can able to see the working prototype of our project, which is done in the small scale, which we can also can do it in the larger scales too. And our project is typically in the practical demonstration you can able to see the 23 volts. That 23 volts is uh, typically enough to glow. I mean like a 3 LED bulbs, because there are 9-volt LED bulbs are so there, and also 9-volt LED bulbs are there, and also 20-volt LED bulbs are also available. The 20-volt LED bulbs are more glower, so we are using that type of LED. In the diagram, the LED bulb is not showing because we have not yet connected it in the but for the multimeter, like it's a numerical value, we are showing it in the multimeter diagram. And for the heat source, we are using here as an iron box, but for the safety precautions, but for our demonstrations. But we can also use the environmental heat surfaces and also exhaust for this purpose. And this is the overall short demo of a project. I assure that we can able to do it in a larger scale too. Thank you.
Next, we will see the feasibility and viability. Feasibility, challenges, and solutions are present in this line graph. First, we will see the feasibility. Take modules, DC to DC converters, ESP32, Arduino boards we are using these hardware components. In these hardware components are readily available. We are also using the IoT integration. IoT integration, what purpose we are using this? Data will be stored in cloud platform. These platforms like ThinkSpeak, Blink IoT. In this project outcome is DC. We are using the inverter. DC will convert it to AC. We are using the Python library for AI-based voltage predictions. What are the challenges are available in this project is sensor inaccuracies, because because slight error in these sensors, these errors are affect the accuracy of the data. Wi-Fi connectivity interruptions. We changing the climate, Wi-Fi connectivity is blocked. So data will be stored in cloud in inaccuracies. Low voltage output from tech in this tech module produce the low voltage output. In this low voltage output may be limit appliances load. Use Next we will see the strategies how to overcome the challenges. We are using the DC to DC converter for stabilize the voltage output. Include the data. We are include local data also. If cloud connection is failed, we collect the data from local data. Implementing the battery management system. Why we are using this battery management system is safe for charging and discharging. Every day we will monitor the source data to ensure the accuracy.
We are going to see the impact and benefits of TEG thermoelectric generator. Here we are using a waste electric recovery system. How it works means converts temperature gradient directly into electricity using Seebeck effect. How Seebeck effect occur means using two dissimilar metals, the electricity is generated from the heat difference. Here, how the heat is generated is from the chimneys and boilers and exhaust pipes. We are recover the heat into electricity. Um, the great relief is it have from the traditional power, the peak load and the using materials are overcost, and from for comparing those materials, we using less materials like filter modules. It's only cost um, 29 rupees to 50 rupees for large amount of filter modules. We can reduce the cost moreover to 29 to reduce 20 also. How it driven for IoT is we use real-time data like voltage, temperature, energy trends, and the heat levels. We are using the IoT, and how the scalability occurs means we can use it macro level and micro level of like household from to industry level. We can generate electricity uh, very efficiently, and this heat energy is already used in many countries, but our country we can't use efficiently, so we go for this product, go for this project to benefit our electricity production. And the reliabilities we can use where the heat generation, we can place the modules and converts the heat into the electricity. And it also come for sustainability of our environment, and also reduce greenhouse gas production. Um, it also have a huge economic return of interest by 2 to 3 years. We can easily take the return of interest from the our project. And also it is system integration very easy. um, we have already enough of components to generate our electricity, and maximum energy is required from the heat. We can also use in many vehicles and home systems, manywhere we can use this, and uh, easily retrofitting our projects in anywhere. Like if we take a exhaust pipe, we can just adding the filter module to take the heat into electricity. Very easily we can change the heat into electricity, and the return of interest is very high, and we can make return of heat into the electricity easy. So we can use anywhere, and wherever we have heat exhaustion, we can use this, and we can take the benefits of heat. Also, we have energy efficient. Overall, utilizing like solar system and windmills, we have to use large amount of material, and the material waste is high. Comparatively, our project take is very low material is usage, and the production of modules also very less amount. By using hybrid tellurium and bismuth and tellurium, we can mix other selenites to overcome the productivity and cost of the bismuth tellurium modules. Like this, we have made many benefits and impacts of our uh, peoples. This is our contents in the impact and benefit. Okay, let's see our other slides and the other importance. Thank you.
We studied three base papers for our project. In first base paper, what we learned is by using Peltier effects, how to generate the thermal energy. In second base paper, what we learned is how the efficiency is increased in thermoelectric setup. In third base paper, what we learned is in which material the efficiency is increased. By combining these three base papers, we implement our project. In first base paper, we said that we studied the Peltier effect, but in our project, we do reverse engineering and we use the Seebeck effect. Um, we believe our project has inspired you. If any queries, comment below, we will address. Finally, our moral is waste is not an end. Opportunity changes in energy. Thanking you.